Hello everyone! Welcome to my channel where I teach you how to be a math genius. If you typically struggle in math or you're looking to improve your understanding of math, this is the channel for you. Also, I will try my best to make these videos user-friendly for teachers, co-teachers, or homeschoolers to utilize as well. If you fall into any of these categories, make sure you hit the subscribe button and the notification bell so that you're notified anytime I upload a new video. Now let's jump in. Today we're going to learn about exponential rules. In my previous video, we learned how to add and subtract terms. Now we're going to learn how to multiply terms, divide terms, and bring terms to a power. By the end of this lesson, you will be able to simplify expressions by using the product rule, quotient rule, and the power rule. I encourage you to pause the video and write your solutions to the problems down for practice, and then continue to watch the video to check your answers. Also, comment any questions you have below. All right, let's get started. Now that we know how to multiply terms, it's time to learn how to divide them. So we have something called the quotient rule. And in one of my previous videos, back in the basic vocabulary video, I talked about how the quotient refers to division. So the quotient rule is going to tell us how to divide terms. So here we have the two terms, x to the a power divided by x to the b power. When we divide those two terms, notice that we put them together as one term where we subtracted the exponents. And if you have any coefficients, you're just going to divide them regularly like you would do any other number. Okay, now it's time to look at some examples of the quotient rule. So first we have this example, x to the sixth power divided by x to the second power. And then we also have the example y to the 14th power divided by y to the 10th power. We need to simplify each expression by using the quotient rule. Why? Because we're dividing the terms. Let's look at this first expression. First, we need to identify the exponents. So the first exponent at the top is 6, the second one is 2, and the quotient rule, since it tells us to subtract the 2, we're going to do 6 minus 2 is equal to 4. Therefore, this is equal to x to the 4th power. Now, why does this work the way that it does? Well, if we go ahead and expand this expression like we did before, the top will look like 6x's being multiplied divided by 2x's being multiplied. And remember, anytime we have factors at the top of our expression and factors at the bottom, which means, they're just terms being multiplied, if they are the same, we can cancel them out. Why? Because anything divided by itself is equal to a 1. For example, x divided by x is 1, 3 divided by 3 is 1, 1 divided by 1 is 1. Anything divided by itself will simplify to a 1. And so that's why we're allowed to cancel these out. And so anytime we cancel something at the top, we cancel the same thing at the bottom. So we can cancel this pair, we can cancel this pair. And notice at this point we have no more x's at the bottom. Therefore, we cannot cancel any more x's at the top. If you count the amount of x's that we have left, there's 1, 2, 3, and 4. And so that's why we get x to the 4th power. If we come to this bottom expression, we have y to the 14th divided by y to the 10th. Go ahead and pause that video, and I want you to try writing down what you believe the simplified expression is. If you said this comes out to y to the 4th power, you're correct. Why? Because 14 minus 10 gives us 4. And we're told we need to subtract our exponents. When we subtract them, we get 4, and that's how we rewrite our answer. Now let's look at some more examples. We have f to the 3rd power divided by f to the 8th power, and g to the 9th power divided by g to the 13th power. We need to simplify each expression by using the quotient rule. Now these are two special cases because they're both going to come out to negative exponents. In the quotient rule, it tells us to subtract the exponents, and if you notice, A always comes first. So, what does that mean? That means the exponent at the top of the fraction comes first, and then we subtract the exponent at the bottom of the fraction from it. So if we look at the exponent in the numerator, we have a 3. If we look at the exponent in the denominator, we have an 8. Therefore, when I subtract the exponents, I need to write the 3 first and the 8 last. This would give us x to the negative 5th power. If we subtract 3 minus 8 in the calculator, we get negative 5. Go ahead and pause the video, and I want you to try writing down what you think the second expression is going to come out to when simplified. All right, if you said that this comes out to 9 minus 13, which is g to the negative 4th power, you were correct. Good job. Now, let's dive deeper into why this works out. So if we expand these expressions the way that we did before, so let's look at the first one. We have 3 f's at the top and 8 f's at the bottom. That's 4, and here's your second 4. Now we also know that we can cancel anything at the top and bottom. That's the same. So F, 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 F. We can't cancel anything else out because though we have 5 more f's at the bottom, we don't have any at the top. And remember, when we divide anything by itself, it comes out to a 1. Therefore, when we write our simplified expression, we put a 1 at the top because since everything disappeared, it doesn't come out to a 0, it comes out to a 1. And at the bottom, since we have 5 f's, we have f to the 5th power. So if you notice, we came out to 2 different solutions here. 1 over f to the 5th power and f to the negative 5th power. I would like for you to pause the video and guess, what does that mean? Why did we come out to 2 different solutions when we simplified the same expression? What does that mean about the 2 solutions? If you said that that means the 2 solutions are equal to each other, you were correct. Good job. So that actually creates a new rule for us that tells us anytime we have a term with a negative exponent, we can rewrite it as a positive exponent in the denominator. That also goes both ways. So if it starts off negative in the exponent, we can rewrite it positive. If it's negative exponent in the denominator, we can rewrite it as a positive in the numerator. So here we have negative in the numerator, and if we rewrite that first one as a fraction, it's over 1, and then it becomes a positive in the denominator, and it goes under 1. And then if it's already under 1 as a negative, then it sits above 1 as a positive. All right, so now let's rewrite the second expression. What do you think it's going to be? Go ahead and pause the video, and I want you to try writing it down. All right, if you said that we can rewrite this as 1 over g to the positive 4th power, you were correct. Good job. It's time to look at some terms being divided with the quotient, with the coefficients. So the first expression we have is 15x to the 6th power divided by 3x to the 2nd power. The second expression we have is 24y to the 14th power divided by 16y to the 10th power. We need to simplify each expression using the quotient rule because we're dividing terms. So in this first expression, we have 2 things here. We have a set of coefficients, and we have a set of exponents that we need to simplify. So the quotient rule tells us that we need to subtract the exponents and divide the coefficients. So that gives us 5x to the fourth power. I would like for you to go ahead and pause the video and write down what you think is going to be the simplified expression of the example below. All right, if you said this is going to be 3y to the fourth power divided by 2, you were correct. Now, let's look at these examples because these can be a little complex. So for the first one, we have 15 times x times x times x times x times x times x. If we expand it, and then we have 3 times x times x. Well, 15 can be rewritten as 3 times 5. So if we cancel everything out that's the same top and bottom, we have 5 and 4 x's left at the top. Nothing is at the bottom, but if we wanted to write a denominator, we can put 1. If we look at the second expression, we have 24 times 14y's. There's 3. There's 6. There's 9. There's 12. There's 14. All sitting above 16 times 10 y's. There's 4. There is 8, 9, and 10. So, if you notice, 24 can be rewritten as 8 times 3, and 16 can be rewritten as 8 times 2. So if we cancel out the top and bottom, that's the same. We have 8 cancel, and all these y's. We're left with a 3 at the top, 4 y's at the top as well, and a 2 at the bottom. And that's how we got our answer. Now, if you look at 24 divided by 16 separately, it's also just reducing the fraction by 8. How do we know we can reduce the fraction by 8? Well, 8 is the greatest common factor between 24 and 16. So we have to divide them both by the same number. 24 divided by 8 is 3. 16 divided by 8 is 2. You can also just put it in your calculator. We have 2 more examples here for the quotient rule. 3r to the 9th power divided by 12r to the 13th power, and 6k to the 3rd power divided by 18k to the 8th power. We need to simplify each expression by using the quotient rule since we're dividing terms. So if we look at this first expression, the quotient rule tells us we need to subtract the exponents. So we have 9 and 13, and if we subtract these, we're going to get -4. And then it tells us we also need to divide the coefficients. So if we divide 3 by 12, we're going to get 1/4. I'm going to show you a little trick here. So if we think about this backwards and put the bigger number on top, we know this comes out to 4, which can be rewritten as 4/1. Therefore, if we look at it backwards, it's 1/4. So that means this is going to come out to r to the negative fourth power over 4. And then we also talked about how we don't want to leave negative exponents in our answer. So when we move that r to the fourth power to the bottom, it's going to become positive, and we leave a 1 at the top. Let's go ahead and try the second one. So I want you to first pause the video, write down what you think the simplified expression would be for the second example. All right, let's examine this. So we have the two exponents 3 and 8. Subtracting those, we'll get negative 5. We also have the coefficients 6 and 18. Dividing those, well, if we look at it backwards, 18 divided by 6 is 3, or in other words, 3 over 1, which means 6 divided by 18 is 1 over 3. So we're going to get k to the negative fifth power divided by 3, which we can rewrite as 1 over k to the positive fifth power with 3. If this is what you wrote down on your paper, you were correct. Good job. If you like this explanation about exponential rules, make sure to hit the like button below and don't forget to subscribe. Thank you everyone for watching. I'll see you in part 3 of this video, the power rule.